Okay. Before data mining, we have to create a layout for gathering data with some approaches. All in all, there are two types of data sampling, such multisensories or with the multi-sensors. In commercial markets, you can see two types of sensors. The first one is multiphysics. At the same time, this sensor can gather in some variables in fluid mechanics, in solid mechanics, or acoustics signals. The other words, there are a lot of single sensors can sense all variables separately. In these two layouts, we can see two types by some mechatronics tools, microcontrollers, besides to connect with the computer. And lastly, we can see in multiphysics just the one data or plots. So in these data, you have to separate some variables in acoustics, in fluid mechanics, and other things. But if you want to use multi-sensor, the another name of the multi-sensor is a sensor fusion. Maybe you can see in research papers about sensor fusions because it's very famous in engineering science. So on that time, you can save the data separately and you can see every plots or subplots at the same time about all variables. Finally, physical variables in this table were categorized in fluid mechanics, such as temperature, pressure. In solid mechanics, about vibration, acoustics, displacement, velocity. So all of these variables are most important if you want to get data. After these, you can analyze in so many data mining. About these multi-sensory applications based on references, there are some factors to be mined during your data sampling about predictive quality controls or maintenance, predictive fault diagnosis, prognosis, and other things. I bolted some vocabularies in these tables. You can see on the effect columns what are the effects in these data sampling. You want to reduce failures, costs, or maintenance, or increasing performance efficiencies, especially harvest energies or decreasing energy waste. And the last one is material properties. It's very important because all of engineering science would like to decrease energy outputs or waste. Why? Because we want to decrease material hysteresis, for example. In the example column, we would like to illustrate some examples about all factors or causes. For example, optimization, minimization, maximization of the system's outputs. So, energy is very important. Up to now, gearbox, airfoils are the most prototype to get data with some techniques. Last columns are defining about the data mining in some techniques or tips and tricks, such as neural networks, fuzzy logics, or other things, especially clustering or regression analysis, or other classifications. So, in multisensory, I want to talk about some items, profit, weaknesses, challenges, and some examples to you. For example, in profit, what are the profits important for you in multisensory? For example, enhanced communication, improving learning for your data mining techniques. What are the weaknesses in multisensory when you want to use some variable or different sensors at the same time but separately? For example, overload. Compatibility is the other challenge or maybe limitations for you, or complexity and cost. About the challenges, calibration and validation are the first items you have to be well done. If you want to have exact data or best data. By the way, in samples of the multisensories, up to now, there are some samples or examples in vibrational science, in acoustical science, or fluid and thermodynamics. For example, initial navigation systems with gyroscopics, accelerometers, or magnetometers. Or in the second columns, two types are very important. Firstly, accelerometers is related to vibrational displacements. And the next one about temperature. Temperature is very good variable if you want to save data, to predict, to examine your system. Yes, this is the other applications about the multisensories. So this is similar to the last table to talk about acoustical, especially sensors like microphone or acoustic emissions, accelerometers in material properties like strain gauges. And these days there are a new science to get data with the cameras like multispectral cameras. So in this type you can analyze with the image processing too. For example, for corrosion or roughness of this surface of metal in metal forming, or tool wear in turning machines. So, what about the multiphysics sensors feedbacks? For example, this slide is like to the the last slides about multisensory. In this slide, we can see about the profit, like accuracy, efficient, are two important feedbacks, and positive feedbacks especially. About the limitations. In limitations of multiphysics are interference and noise. Maybe there are so many uncertainties in using multiphysics sensor, because this type of sensor must sense and monitor of the system with some variable types of feedbacks or signals. So, for example, temperature in fluid mechanics is completely far from than vibrational acoustics or vibrational displacement. These days, some companies around the world are producing samples in multiphysics sensors, such as environmental. Environmental sensor can sense temperature, pressure, and volatile organic compound at the same time. It's a very good challenge, but we have the other problems, especially for the next step in data mining. Initial measurement unit can monitor accelerometer and gyroscope at the same time, temperature and humidity sensor, gas and particle sensor, pressure, temperature sensor, and acoustic vibration sensor. I would like to illustrate this slide about literature review since 2019 up to now. I studied 61 research papers, so this slide is very valuable for me because I could extract some tips and tricks, methods, techniques to show to you about the applications of multisensory, academically especially. If I want to say about application, these days condition monitoring and health monitoring are the first items and first science for engineering to solve so many problems. In health monitoring, in agricultural science about the fruits, to be health of the fruits or fail of the fruits too. In CNC, in rotor, in gearbox, pump, pressure forming, and so on, the bold vocabularies in the first column are using and searching about the problems. The second column I underlined with some colors, green, red, yellow, and brown, about the diversities of these variables before mentioned to you. Preferably, most useful variables, if you want to get data, firstly is displacement, is related to vibration. The next one, sound. Sound is very good feedbacks if you want to get data, and after that to do data mining approaches. And the third variable is temperature, is very, very suitable to examine of your system. In conclusion, I draw some blocks about the procedures of experimental method and data mining. Firstly, you have to know about the physical model. After that, you have to detect what you want, which variables are important for you, like sound, displacement, temperature, and after that, extract effect or feature selections is very important. From the blue box to the next blocks, you have to start data mining, because after you exact your feature selections, you have to start to data mining with all methods in data mining. So two blocks are data acquisition. The number 3 and 4 blocks are soft computing. And the last one is implementation to get data. So, state of the art of all activities are the number 2 and number 4 blocks. So, the whole of blocks is defining experiment, observation, and identification system, because after the gray box, you have to predict or solve the problems to present solutions. So, there are some key questions, in my view, about which variables is important for your system. After that, what theory is suitable to data mining or feature selections? The next one, do you know what are noise and uncertainties in your systems? After that, you have to create solutions for your systems. And finally, you have to verify your signal. Your signal is the best reference to get solutions or not. So these are my references. So thank you for your attention.
Mr.
Yes, Hassan. Yes.
Hassan.
Yes, yes.
Yeah.
Thank you.
He gave us a brief review.
Yes, thank you.
On actual demand of determining
yes.
various engineering, especially in